Mr. Harris here, and welcome to a new video of Unit 11. In this video, we're going to continue learning how we could balance chemical equations. Okay, so we'll be doing these two examples. So write the balanced chemical equations for the reaction of sodium with air, question A, and question B, aluminium with oxygen. So if you recall, this looks pretty familiar. You've already learned in this unit the reactivity of metals with oxygen, and later on we'll be trying to balance chemical equations with water and hydrochloric acid. Actually, in the previous video, we've already learned how we could balance the chemical equation of acid. In this one, let's try some examples with balancing with air or oxygen. Okay, let's look at question 8. Balance the chemical equation for the reaction of sodium with air. Essentially, it's just saying react with oxygen. So let me go ahead and write down first step. What is the first step? We'll need to figure out what the reactants are and what is the product. So over here, sodium. Sodium metal is, what's the chemical formula for sodium metal? Let me use this color. For sodium metal, it is Na. The chemical formula, you can refer to your periodic table. Okay, this reacts with oxygen to form what? So I know this is a plus because it reacts with air is oxygen, as I mentioned just now, O2. And what does it form? The question doesn't state any product or any other products. So how do I know? So this is where your prior knowledge or your prior concept of this particular type of reaction comes in. So if you remember the word equation, the metal plus oxygen, so in this case, sodium plus oxygen, you would get sodium oxide. So that is the product being formed. Okay, again, in the exam or in your quiz test, please do not write down this word equation. It's just for your understanding. If you know the reaction of sodium with air, the product you get is sodium oxide, then very good. Go ahead and start writing down the chemical formula for that. Okay, what is the chemical formula of sodium oxide? Again, you can refer back to my previous videos on how we could write the ionic formula. You can just check on the chemistry playlist, play that video, and come back over here if you're forgotten. So sodium ion, I know this is Na plus. On the other hand, oxide ion, I know this is O2 minus. Are the charges balanced? No, they aren't balanced, so how can I balance them out? I could add one more sodium ion. So I got sodium plus over here. Overall, on the left hand side, I have 2 plus charge. Right hand side, I also have a 2 minus charge. So this helps me to balance them out. So when I write down the overall formula, what is it? Left hand side, I have 2 sodium ions. There are 2 of them. So I'm going to write down Na2. Right hand side, I have only 1. So it's O, just the single O. So Na2O. Alright, so that is how you find out the chemical formula. So let me rub this out and just write down the chemical formula. I would get Na2O. Let me leave some space actually. Na2O. Perfect. Okay, now this is the initial chemical equation that I get. Now I'll need to balance it. Again, as I've told you, I have a habit of starting from the left. So let's look at the left over here. How many NAs do I have? Is there any big number, any coefficient? No. Is there any small number? No. That means there is only 1 sodium over here. Right hand side, sodium is over here. Any big number? Any coefficient? No. Okay, we'll leave that. We don't need to focus on that. Any small number? Yes. There are 2. Okay, now let's focus on whether they're balanced. Left hand side, there's only 1. Right hand side, there are 2. Balanced? No. So I'll need to balance them out. And how am I going to do that? I just need to times 2 on the left hand side. Left hand side times 2, I'll get a 2. So balance now. Yes, we're happy. So now how do I write it into the chemical equation? The 2 over here, you'll write it in front of the Na. You'll write it as the coefficient 2. Right, all good. Okay, we've balanced the Na. Oh, let me undo that. All right, now let's look at the next one, oxygen. Over here, no big number, but I have a small number, which is 2. Over here, I don't have a big number. I don't have a small number, so just by itself, 1. Is it balanced? No. So in order to balance it, again, right-hand side this time, I'll need to times 2. So the coefficient that you write, we'll be writing in front, similar to what I've done for the sodium on the right-hand side, left-hand side, sorry. So now I'll write it like this. Okay, now is this the balanced equation you get? You'll notice one thing very interesting. You'll say, Mr. Harris, something very weird happened. When I added the 2 over here, how many sodiums do I have right now over here? Okay, so because I have 2 Na2, it is essentially what it means is Na2, there are 2 of them. So in total, how many Nas are there? In total right now, I have 2 over here, 2 over here. So in total, I have, let me use a different color. I have 4. On the right hand side, I have 4 NAs. How about on the left hand side? On the left hand side over here, I have only 2. Is this balanced? No. So what can I do now? Very simple. You balance it again. You rebalance it. So left hand side, I would just do times 2 so that I get 4, right? And on the right hand side, it is 4. So now I need to put 4 in front of there so I can rub this out. I'll put 4 right now. 4 Na. So now let's see whether this is balanced or not. Let me rub everything out so it's easier to see. Okay, rub. Okay, let's count one by one. Okay, over here, let me use red. I have 4 NAs. And over here, the big number I have 2. Small number I have 2. That means I also have 4 NAs. Perfect. This is balanced. Now over here, how many oxygens do I have? I have 2. How many oxygens do I have over here? There's no small number, but again, I have a big number over here, which is 2. This is also balanced. So in total, as you can see on the left side, I have 4. You could say sodium atoms. Right hand side, 4 sodium atoms. Left side, I have 2 oxygen atoms. Right hand side, I have 2 oxygen atoms as well. So overall, this is the final chemical equation. Is this the final, guys? No, I'm missing one thing. The physical states, the state symbols. So you can go and write it down. Sodium, I know it's a metal, so it's a solid. Oxygen is a gas. Sodium oxide is actually also a solid. Okay, so there you have it. The balanced chemical equation. So one thing to note over here is just now how I was showing you that I was balancing it. So when I balanced it out, I noticed that the sodium over here, they weren't balanced out, so I just rebalanced it. So guys, it's going to be a trial and error. It's not very simple in the beginning, but eventually when you get the hang of it, you'll get used to it. So using the same concept, let's try and answer question B. Aluminium with oxygen. Okay, let me do it up here. Aluminium, what is aluminium? The chemical formula? Al. And then you got the plus. Let me use black. Oxygen is O2. And then I would get, this time I'll get aluminium oxide. Aluminium oxide. Okay, for aluminium oxide, I know that aluminium is Al3 plus. Oxide is O2 minus. Now guys, you guys do it by yourself. How can I balance this out? I'm just going to straight write down the chemical formula. This is going to be Al2O3. Okay, you can work it out by yourself, or you can refer to the previous video. But this is what you get. The chemical formula you get is Al2O3. Now, I've already learned my lesson last time when I started from the left-hand side. It was difficult, right? So what if I start from the right-hand side? Actually, it's going to be more or less the same thing. Because let's look at Al first. Al over here, I have 2 over here, right? And on the left, I have only 1. So I'm going to balance it out. How can I balance it out? I'm going to add a 2. So when I do this, I get 2Al. How about on the next one? Oxygen. Over here, I have 2 oxygen. On this side, how many oxygens do I have? 3. How can I balance them out? I'll be using the same method, LCM. Okay, you just need to find a way to balance them out. So the LCM of 2 and 3 is 6, essentially. So you can just do times 3 on this side and times 2 on this side. So that you would get a 6 over here. You will get 6 over here as well. So again, because I did times 3 over here, I'm going to write it over here, 3. And because I did times 2 over here, I'm going to write 2 over here. Okay, let me rub everything out so it's easier to see. Okay, now we'll need to look at the aluminum again. Aluminum, this time again, this is only 2 on this side. Over here it's changed, there are 4. So in this case I need to times 2, which is equal to 4. So they are balanced. So let me go ahead and put the times 2 over here. 2 times 2 is 4. So I'll need to change this to 4. So let me just change it to 4. Let me use this color. 4Al. And on this side, I also have 4. So now you can go ahead and try it by yourself. Let's see whether they are balanced. On this side, how many Als do I have? I have 4. On this side, how many Als? How many aluminiums? 4. How many oxygens? Now let's do the oxygens. Over here, 3 times 2, I have 6. Over here, 2 times 3, I have also 6. So on the left side, I have 10 atoms in total. And on the right hand side, I also have 10 atoms in total. So please make sure you also count the atoms once you have done balancing them out. So don't forget, last step, you need to add back the physical states. So this is solid, this is gas, this is a solid. Okay, so what have you learned from this? What you've learned is whether you start from the right hand side or whether you start from the left hand side, it's more or less the same, guys. So you can try both ways, whichever suits you, it's totally fine. At the end, make sure you just get the balanced chemical equation. Okay, so these were actually some tough questions. These were not simple, but later on they're more or less going to be of the same difficulty. All right, that ends this video. I'll see you guys in the next one. Bye.